Hello everyone, welcome to chemistry class. Today we begin the part 4 of this chapter number 3. Until the last class we have started the topic of bases and their classification. Let us begin the next topic, that is preparation of bases. Bases can be prepared in the following methods as we will be discussing now. The first method is from metals. By using metals and on their oxidation, reacting the metal with oxygen, we can get a particular base. The base will be actually what? It will be acidic oxide of any metal, that is a metal oxide. Like here we can see Na, that is sodium is a metal, it reacts with oxygen, and what we are getting is sodium oxide, that is Na2O. It is a metal oxide, and metal oxides can be a base. Next one also, one more example you can see. So these are all active metals: sodium, magnesium, any other also you can take, like calcium can be taken, potassium can be taken. For example, potassium reacts with oxygen, we will get K2O, that is potassium oxide. Then we can balance this equation in our own way, that is the formation of a base. Next, now by the action of water, this is what we are doing. We are adding water to the metal. This metal we are using, and this metal is reacted with water. On addition or the reaction of water with this active metal, what we will get? We will get a base or alkali, that is we will get a soluble base. The water soluble bases can be formed by this method because they are soluble in water. Apart from this, what will form is hydrogen gas will form. So the general equation says what? The active metal plus water, on adding with water, we will get soluble base and hydrogen gas. So this is another method to prepare hydrogen gas also. Equations you can see, all these can be used only for what? Only for the soluble bases, because they will, if we use any other metal here, for example, if we have to prepare the alkali, if we have to prepare a base of using the iron metal, like we have to prepare FeOH2 or FeOH3, then we will not use this method, because FeOH2, that is a insoluble base, that is water insoluble, so that cannot be formed. This method can be used only for alkalis which are water soluble bases. Next method is third one, by the action of water on soluble metal oxides. Here what we are using is we are taking a metal oxide and we are adding it with water. In the first method only, here we have seen what we are preparing. We are preparing a metal oxide. We are preparing a metal oxide, and this metal oxide is only put to reaction. This only is put to reaction or put to use. It is added or reacted with water, and what will form? We will form an alkali. So this method is also used for the preparation of alkalis. Any metal oxide like sodium, if you have to prepare sodium hydroxide, then you use sodium oxide. Similarly for potassium, accordingly we will choose the element there. So you can see here all the metal oxides on dissolving in water, what they are giving? They are giving their alkalis. They are the soluble bases. Next method is called as double decomposition. It can also be called as the double displacement reaction. What is happening in this reaction? You can see here, first we are taking a salt solution. This salt actually we will learn after the bases. Acid bases we have learned, salt is a part of the chapter, we have to learn further, but here a reaction is coming. So what we have to do in this reaction, this salt solution, these salts can be of two types. One type of salt are called as soluble salt, another one are called as insoluble ones. Now what are these soluble and insoluble? We'll deal with them in details in the topic of salts. In the upcoming videos you will see. But here you have to take a note, for the preparation of this base in this reaction, the salt we are using is a salt solution. That means what? The salt which is soluble. So in other words we can say what we are using in this reaction is a soluble salt. We will use a soluble salt and a alkali, that is a soluble base. So both should be soluble. Next one, what we will get as a result is basic hydroxide. We will get hydroxide and we will get normal salt. So equation you will see the reaction is given here. So, one example we will read, that is a soluble salt. What are soluble salt? That we will deal with in the topic of salts, because here it would not be fair to begin the next topic before finishing this one. So just you have to remember for now that we are using soluble salt. So FeCl3 perchloride we are using with this soluble base, that is an alkali. Here what is happening? Double decomposition or double displacement is happening. So what are happening? Oppositely charged ions will bond together. Na and Cl will form NaCl, that is a normal salt. The remaining one is iron, Fe and OH hydroxide, that will combine together and form this FeOH3. Similarly, in the next one also you can see sodium and sulfate, that will form the salt Na2SO4 sodium sulfate. The remaining ones are copper and OH is hydroxide, that forms CuOH2 copper hydroxide. So this is what is happening. Oppositely charged ions are exchanging each other, they are displacing each other. That is why this reaction is called double displacement reaction, or it can also be called as double decomposition reaction. I hope it is clear to you. The general equation you have to learn in all these reactions you have to learn. Next, the fifth method is by the action of oxygen on metal sulfides. Now the remaining methods, 3 more are there that we will be using. It will include the compounds of any metal. So here it is metal sulfide. We will use metal sulfide and subject to oxidation, that is addition of oxygen will be done. So metal sulfides on action of oxygen, what they will produce? They will produce metal oxide. From here this sulfide will be removed, this sulfur will be removed by oxygen, that is addition of oxygen takes place. Addition of oxygen takes place where? It takes place to the metal atom. To the metal, addition of oxygen takes place. As a result, what is produced? Sulfur dioxide gas is produced separately. Let us see the example here. Zinc sulfide, that is ZnS. On addition of oxygen, what is happening? The sulfur is removed from here and we will get oxygen. Oxygen replaces that sulfur and we will get the oxide, the metal oxide. This metal oxide is what? It is a base. And remaining what we are getting is sulfur dioxide, that is a byproduct of this reaction. Similarly, one more example, lead sulfide, PbS, lead sulfide reacts with this. Here also same thing happens. Oxygen is added to the metal, that is lead there, and we will get lead oxide, PbO, and byproduct is, that is sulfur dioxide. Let us have a look on the next metal compound used for preparation of bases, that is metal carbonate. Here it is a decomposition reaction, that means a bigger compound, a bigger molecule is breaking into smaller parts. Let us have a look here, that this is calcium carbonate. Here you can see the symbol is given, this symbol is called as heating. So we are subjecting this compound on heating, calcium carbonate on heating. What will happen? The decomposition will take place. This compound will break down into 2 parts. One will be a basic oxide, another one will be carbon dioxide. This is a byproduct. A byproduct is an additional product which is formed along with the main product. The main purpose of this reaction is to prepare a base, that is the product. Basic oxide is the product, extra thing is forming, that is carbon dioxide, that is the byproduct. The next example also you can see copper carbonate, CuCO3. It also decomposes into 2 parts. One is copper oxide and that is the base, another one is carbon dioxide, that is the byproduct. Next one, in this case we are seeing an exception, that is sodium and potassium carbonates. They do not undergo this decomposition reaction. Carbonates, we have seen metal carbonates, but here sodium carbonate and potassium carbonate will not show any kind of on heating. The last reaction for preparation is given here, that is with the case of metal nitrates, that is NO3 minus, that is nitrate ion, NO3 negative radical. So here we can see the example. Here also it is decomposition only. A bigger compound on heating breaks down into smaller compounds. One is the base, metal nitrate on heating gives us base. Second thing what we are getting is we are getting nitrogen dioxide gas. The third thing we are getting is oxygen gas. So these are the 3 products we are getting on the decomposition of metal nitrates. Let us have this example, calcium nitrate. So what it will give? It will give us calcium oxide, and remaining 2 things can be nitrogen dioxide and oxygen. For learning this, for making it easier, when you are writing the equation, first you write this compulsory ones. First you write the calcium nitrate. Out of this you remove this. Out of the main compound you remove NO2 and O2. Whatever remaining molecular atoms will be there, that will be the base only. That is an easier method to remember these equations. So the next also is similar here. The last equation, that is, or the preparation is given here, that is of ammonium hydroxide. How we can prepare this? That is a simple method. We will take ammonia gas, that is NH3. Ammonia gas on dissolving in water we will get NH4OH. That is the last method of preparing the bases. So all the different methods we have seen for preparation of bases. Now we will move on to the properties of bases. First of all comes the physical properties of bases. In the acids we have seen the taste was there, it was sour taste, but in the case of bases, they are having bitter taste. They have a sharp and a bitter taste. And the indicators, in the case of acids we have seen this different indicators are there. What are indicators? They are complex compound which indicate which show a color change with reference to the acids or base. We are, if for example we are having a solution is there, a solution is given to us and we have to identify this solution is acid or this solution is base, what it is. So what we will use? We will use an indicator. We will put indicator into the substance or into the solution according to the color which is coming in that content in the test. Whatever color is coming, we will assume we will get a result that the substance is acid or base. So here we are learning the base. First indicator here is litmus solution also is there, litmus paper also is there. There are two colors, red litmus as well as blue litmus. In the case of bases we are using red litmus. This red litmus will change its color to blue litmus, that is red color changes to blue. In the solution also if we have the litmus paper, then red litmus paper will turn into blue litmus paper. On the opposite, in the acids what we have to use? We have to use blue color. For the acids we have to use the blue litmus, that blue litmus will change into red litmus, that is for acids. But in the bases it is opposite, red will change into blue. The next one is methyl orange. The methyl orange, that color changes to yellow, orange to yellow in case of base. Next one is phenolphthalein. Phenolphthalein shows pink color in the case of bases. Last one here is given insoluble bases. The water soluble one, the alkali only we can use. Generally the insoluble bases are not indicated with the help of indicators. Next property of the physical property is these are slippery to touch. All the bases are slippery to touch. They are soapy substances. The bases are slippery to touch. This can be understood by the concept that is given here, that is caustic soda and caustic potash. Both of these are strong alkalis. What is caustic soda? Is NaOH. That is the common name of NaOH is caustic soda. Similarly KOH, potassium hydroxide, it is commonly known as caustic potash. Both of these are strong alkalis, and alkalis whenever they react with oil they will produce soap. So the reaction we can write is alkalis plus oil. It will give us what? It gives us soap. That is why these are soapy to touch. Now you may be assuming, if you are touching it from where this oil is coming, the oil is naturally present in our skin. In the human skin, oil is naturally produced. So whenever we touch any alkali, the oil that is in our skin, it reacts with this alkali and it produces soap, and we feel that the substance is soapy substance, or you can say it is a slippery substance. So that is due to a reaction that naturally happens when you touch any alkali. Next one, the point number 4, they are all strong electrolyte, that is they can conduct electricity because the bases can dissociate, they can ionize easily. Like NaOH, it can ionize into Na plus and OH minus. So because they can form separate ions, they can dissociate into ions, they are strong electrolytes. The point number 5, the last physical property is they show a mild corrosive action. Corrosive action is what? Related to the burn injuries. If we touch them, or if we touch them, then we can experience some kind of burning in our skin. So this burning will not be that much severe as in the case of acids. Acid we cannot even dare to touch, but in the case of bases, this burning action will be mild. It will not be that much serious, but still we have to be careful while using all these things. That is all for the physical properties. We will now move on to the chemical properties of bases. The first chemical property is regarding the absorption of carbon dioxide. All these strong alkalis, which one? The strong alkali. The strong alkali means what? Alkalis are of what? There can be sodium, they can be potassium, they can be calcium. All these hydroxide, we have learned in the last class, hydroxide of sodium, potassium, calcium are alkalis, and these metals are very highly reactive. Among these, the sodium and the potassium especially are the most reactive ones. So these alkalis are called strong alkalis, and they can absorb carbon dioxide easily. Whenever they are subjected to reaction with carbon dioxide, this will be absorbed by the strong alkali, and we will get what? We will get a carbonate salt. A salt is produced. Carbonate salt is produced and water is produced. So this is the general reaction. You have to remember this. Strong alkali plus carbon dioxide, we will get a carbonate salt and water. Let us look at the reaction here. NaOH plus CO2. What we are getting is, we are getting Na2CO3. The remaining thing will be water. Similarly, in the case of potassium hydroxide, we will get potassium carbonate, remaining thing will be water. The second one is already we have been seeing in the acids also, that is the neutralization reaction. Same reaction, in this same reaction only bases are forming a part of this reaction. That is why this reaction can be given in the chemical properties of bases also. Acid are also there, so we can use this same reaction in the chemical properties of acid also. Reaction we have already understood, I will not go into details now. The next third one is they precipitate as insoluble metal hydroxide when added to the solution of heavy metals. So here you can see a metallic salt is taken, and this metallic salt, when they are subjected to reaction with an alkali, that is water soluble base, then what we will get? We will get a salt and insoluble hydroxide. It will be more clear now. Let us look at the reaction here. First one is copper sulfate. Copper sulfate is a metallic salt. Copper is a metal and its salt is copper sulfate. It reacts with this alkali, that is ammonium hydroxide. What we are getting here now? We will get this ammonium sulfate, that is the salt, and remaining thing will be what? It will be insoluble hydroxide. How we can say it is insoluble? You can see this downward arrow. Downward arrow means what? That this compound has settled down in the container where this reaction is happening. In the test tube, for example, in the test tube this reaction is happening, then at the bottom of the test tube you can see that copper hydroxide will settle down. That is why this downward arrow is shown. So this indicates it is insoluble in nature. Next one, zinc sulfate, also similar reaction. It will show that this is a metallic salt, and here what we will get? Sodium sulfate will form, that is the salt that will form. Remaining thing will be zinc hydroxide. Last also is similar, sodium sulfate is formed, and remaining thing will be iron Fe and OH2, that is hydroxide, iron hydroxide. The next and the last chemical property here is point number 4 is here. In this reaction what is happening? Whenever we are using any alkali, that is soluble base, and it is subjected to reaction with any ammonium salt, ammonium ion is NH4 plus, that is ammonium ion. Its salt, that can be ammonium chloride NH4Cl. Here we have ammonium sulfate NH4 whole twice SO4. So in this salt NH4 should be there, that is ammonium salt. So ammonium salt plus alkali, what the product will be? One thing, ammonia gas will be released. Ammonia gas is NH3, that will be released. Second thing, water will be formed. These two things are sure to happen. The next thing will be a salt will be produced. Now what salt will be produced? That will depend on the metal which is present in the alkali. You observe now in this reaction, all these three reactions are having different metals, and according to that the salt is forming. Let us have a look here. First of all, ammonia is in all these reactions. Water is also present in each of these reactions. So that is simple to remember. Water and ammonia are there. But salt, how to understand which salt will form? Now you see here alkali, that is here it is NaOH, sodium hydroxide. It is containing sodium metal. So salt also will have sodium in it. Next one, here you can see calcium is there. Salt will also have calcium in it. Here last one, alkali is KOH, potassium hydroxide, potassium metal is there. Salt will also be of potassium only. The next radical, that is the negative radical, that will depend upon what? That will depend upon the negative radical of the ammonium salt. In this case ammonium salt, what is there is chloride, the chloride ion. So chloride is coming in this salt. Here also Cl, here it is SO4. So one positive radical is coming from alkali, the negative radical is coming from the ammonium salt. This is the reaction, ammonium salt on the reaction with alkali, it gives salt plus water plus ammonia. That is all the chemical properties we have seen. First one was addition of strong alkali with CO2. This is what is happening. Absorption of carbon dioxide is happening. The strong alkali absorbs the carbon dioxide, and what is formed is carbonate is formed. Second one is neutralization reaction. Acid plus base gives salt and water. That is already we have done in details earlier. Next one reaction is what? Here it is about that metal hydroxide are formed, and these metal hydroxides are what? They are insoluble and they settle down at the bottom of the container where the reaction is happening. The reaction is between what? The reaction is between a metallic salt and then alkali. What is produced? Salt and insoluble metal hydroxide is formed. Next, last one, just now we have seen ammonium salt with reaction on reacting with alkali, it is giving what? Salt, water and ammonia gas is released. Let us now come to the general uses of some bases. Some bases are given. All these you have to remember. You have to learn this table. First is sodium hydroxide, that is having a common use. The different type of soaps can be manufactured using sodium hydroxide, it is also called as what? It is called as caustic soda. Next one is potassium hydroxide, that is KOH, it is called potassium hydroxide, common name is caustic potash. Where it is used? It is also used in the case of soaps, but major uses in where it is used in alkaline batteries, different kinds of batteries, like the rechargeable batteries, battery cells are there, rechargeable ones, they can be containing potassium hydroxide. Next one is calcium hydroxide, it is used in preparing bleaching powder. It is not bleaching powder, don't confuse that bleaching powder is calcium hydroxide. No, calcium hydroxide is one of the chemical used to prepare bleaching powder. Bleaching powder is different thing. So it is calcium hydroxide is used in preparing bleaching powder. Next thing is it is used to soften hard water. Water is of different type, you learn in the lower classes. Water can be hard water and soft water. So the hard water can be softened using calcium hydroxide. Next is magnesium hydroxide, it is used as a medicine, as an antacid. So whenever you have acidity in the stomach, it can be used as an antacid, that is magnesium hydroxide, that is MgOH whole twice. Next one, aluminum hydroxide, that is used where? It is used in fire extinguisher. Next one, ammonium hydroxide, NH4OH, is used for what? It is used for removing the grease stains from clothes. In case clothes become dirty due to grease, that stains of the grease can be removed by putting this solution of ammonium hydroxide. Number 7 of magnesium, that is MgO, that is magnesium oxide, where it is used in making refractory bricks. These are special kind of bricks which can withstand high temperature. Generally where it is used? In the furnaces. In the furnaces, what is there? Fire is burning every time, some process is going on, so that the bricks which are around them in the furnaces, they are all refractory bricks, they can withstand high temperatures. The last one is calcium oxide, it is used as a drying agent. Next one is used as a basic flux. Flux is what? We will be learning this basic flux in details in chapter number 7, that is metallurgy. In this class 10 only we will learn. Just in short, I can tell that flux is used. What is flux is? It is a kind of substance which is used to remove the impurities. It is used to remove any kind of impurity from what? From the minerals. When we are extracting the minerals from the earth's surface, different kind of impurities can be there, so they can be removed by using flux. Full process in detail we will be learning in the upcoming chapters. That is all for the uses of bases. The next topic, that is about the test for acidity and alkalinity, that is regarding the pH levels, how we can measure the pH of different acids and bases. And the upcoming exercise part, this we will be doing in the next video. Here we will be taking a pause in the present video. The next video also you will be getting today itself. By evening you will be getting the next one. So that's all for this one. Thank you. Do wait for the next video.